Hello, this is Jose Luis here at Parametric Camp, and welcome to a new video on this series, Advanced Development in Grasshopper. Exactly. So, what are we doing in this video? This is going to be a hands-on. We're going to continue developing the plugin, the Parametric Camp plugin that we've been doing in this series. And for this video, what I would like to teach you is hands-on examples of how to do error handling. And error handling is the situation where the code for some reason fails, and it fails because the operations that we are demanding from the code are just not possible, or because something in the code is poorly written. So there are actually techniques to make sure that even if the code fails, we can default to safe values, and we can also give users warnings and information about those errors. So for example, if I am trying to get an item from a list that doesn't exist, then maybe finding this, giving this kind of warnings about, hey, the index is too high, you shouldn't be doing this, or maybe if you're giving it a negative value, which is something that you shouldn't have, then maybe index is out of bounds, or if you're giving it a path that just doesn't exist, then the component will give you some warnings about that. So all of that in Grasshopper is very doable. And I'm going to teach you in this video some techniques of how to implement error handling in Grasshopper components so that you can give more informed feedback to your users. This is typically a very good practice because it helps people understand what's going on. Okay, so let me show you that. But before we do that, just make sure that you check my previous video where I explained how I did this. Okay, so let's get hands-on. Let's start simple. I think a good place to start is going to be the remove components, the ones that removed items and branches, etc. So for example, let's take a look at this one. If we have a data tree that has 3 branches and 5 items, then I can probably remove the first one, the second one, the third one, fourth, the fifth, and then when we go into the 6th one, because there aren't that many elements, you can see that the components themselves already fail. But they fail because the code that is running inside of them, so actually trying to access element number 6 on the list, is throwing an error. And then the component itself throws the error because the code inside is not working. So I wonder if we can implement something where we handle this. So for example, for remove item, I think what I would like to do is I would like to, if the index is out of range, if the index is greater or smaller than the size of the collection, then what I would like to do is I would like to display a warning message, but I would like to still output the full list by like it is. So what I'm going to do here is I'm going to say, first of all, I'm going to implement some sanity. I'm going to implement some sanity. This is a common way of referring to making some checks and make sure that all the data is correct before actually doing any kind of algorithm, right? So what I can do here is I can say sanity is going to be that if I is less than 0, if someone messed up with a negative index number for whatever reason, or I is greater than L dot count. So how many elements do we have? If L is greater than that, then it means that this does not work out. So what I'm going to do is I'm going to say component add runtime warning, and then here I'm going to say this sucks so much to type all the time. I will show you in a few videos how to develop outside of Grasshopper so that you can get nice autocomplete. And then here I'm going to say warning, and then I'm going to say index out of bounds. Okay, and then what I'm going to do is that I'm going to make sure that I pass out the full thing. I'm going to pass out the full list, all right, as it is, without removing anything. So I'm going to say L out is going to be equal to the full list, L, without doing anything else, all right? Now, this is not going to work entirely, and let me show you why. So I'm going to hit OK, and then I'm going to go back. So now it works well, etc. But now you can see that I'm still getting the error message and I'm still getting the index out of range problem. This is because I have done some sanity here, all right? You do the warning message, I spit out the list, but the component, the script still keeps executing. So after this happens, the component still tries to remove that item, so therefore it hits the error, and that's why the component raises the red error, like, oh, this is index out of 0, everything failed, blah, blah, blah. So what I need to make sure is that if this is the case, this is the only code that runs. The compiler doesn't keep going throughout the code. The only way to do that is that because this is a function that we're executing, and because it's a function that returns void, that doesn't return anything, we can at any time during the execution of the function just type return. And if we type return, then at that point, the function will stop executing, will return void, and then the rest of the code will not execute. So this is the way to put a stop to the execution of the code. And if that is correct, then this should probably work now. All right, so, okay, so it's not working. Then let me take a look at what's going on. Oh yeah, very dumb mistake. I actually made two mistakes. So one is that I said that I had to be less than 0 and greater than count, which can never happen. So this is actually, instead of being an and, it should be an or. So that's one thing. So I'm going to run this, and you can see that now for the value of 10, this is telling me index is out of bounds and it's outputting the full list. And then if I scroll down, you can see that things work, except when I hit number 5. And that is because I forgot that it's not count, but it's count minus 1. So if I do this, now this works. And you can see that now 4 is good, all of them are good, x5 is good, and then the whole thing is output, and then any other value is going to work, okay? So you can see that now this component is a little smarter, and it gives me better functionality, it doesn't just crash right away, okay? So all of these practices are actually really good. So the next one we're going to see is a very similar one, which is remove branch, right? So for example, let me crank this up a little bit here. So let's say that I'm going to, so I don't even know how many branches we have, but let's say we have 25, okay? So here at the remove branch, you can see that at some point I have way too many branches. How many branches do I have? 12? I have 15 branches, okay? And then what I'm doing here is that I'm trying to remove some of the earlier one, but then as I go beyond 15, you can see that the component is not really doing anything. So the component is working, it's not crashing. However, it's also not telling me anything about the fact that I'm not removing anything here, that I went beyond the amount of branches that are available in this tree. So I may want to also clean that up. So I may want to say here, sanity, I'm going to say if I is less than 0, or this time I'm going to do it right, or I is greater than how many branches do we have on the tree. And then we're going to find that by saying t dot branch count. So that's how many branches do I have. If I is greater or equal to that, or is greater than this minus 1, then what we're going to do is we're going to output an error component add runtime message Grasshopper runtime warning level dot runtime message level. I never remember. Message level dot is going to be a warning, and then index out of bounds, and nothing really happens. And in this case, we don't really have to change anything else, because since the component was working fine and it was outputting the rest of the tree, we don't really need to change the output, or we don't really need to do a return here. In this case, we don't need that. So for example, here, index is out of bounds, and then when I hit 15, I'm still out of bounds because remember it's one less. And then for 14 is when I start removing the last branch. You can see there. So now you see, blah, blah, blah. So this component now works a little better. It's a bit more explicit about what is going on. The last one we're going to do for the remove branches is going to be this one here, the one that says remove branch by path. What we can see is that if we right now enter a path that doesn't exist, so for example, 1002, nothing happens. So this basically returns the same branch without any kind of message or any kind of warning. And that is because for whatever reason, the remove path function inside of the tree is not really telling us anything about that. So I wonder if t.removePath returns true or false, whether if it succeeded. And I can see that it doesn't look like that's the case. It's just a void function. So it turns out that I can not use some information from the method to make sure if this operation was successful or not. So the way that I'm going to do this is that I'm going to add a little bit of overhead. I'm going to say check if path exists. All right. And then what I'm going to do is I'm going to use another method inside of data trees, which is t.pathExists. So you see that there is a method that returns true or false if the path that we're giving it exists or not. And then what we can see is that t.pathExists requires a bunch of numbers or is asking for a Grasshopper path object, which we already created back before here. So what I can do is if t.pathExists equals true, or we know that we can shortcut this is the same, right? If this is true, then actually what we want to check if this is false, right? If this is false, then I can say component dot add runtime message, and here Grasshopper runtime message level dot warning, and we can say path does not exist. But we let the rest of the component work as if nothing had happened because we want to output the rest of the full path. Okay, so you can see that now at this point path does not exist. So if I go back to 1, this is probably going to work, and if I change this to 200, this doesn't work because this did not exist. Okay, so we can go back here to number 2, and that is fine. And then that component works much better now. It gives me some warnings. Okay, beautiful. So how about getting stuff? How about reading from the components? Can we improve those too? Okay, let's take a look at the GetItem component. The GetItem component can fetch from a tree, from a list, the first, second, third, etc. We've already seen it. It just takes whichever one, right? But if we go beyond how many elements there are, it gives me this error, which comes because this component, this code is actually breaking. It's breaking here because we're using array access on an item that doesn't exist. Okay, so we probably want to improve that. First of all, we probably want to implement our own error handlings, and then on top of that, we may actually want to offer an alternative if that doesn't work. So first of all, let's implement our own sanity here. So sanity, if I is less than 0 or I is greater or equal to the amount of objects. So okay, so if that's the case, then we probably want to do is we probably want to say component add runtime message, and that's going to be Grasshopper runtime message level dot and let's say we do a warning and we say here index out of bounds. And then because we're out of bounds, what we want to do is we want to make sure that we output something. So we're going to say I out is going to be equal to null, so an empty object, an object that doesn't exist, and we stop the execution of the code. Remember, we're doing this so that we don't execute this line and we don't fall on the default error that the component was giving us because this code is just not working. All right, so I'm going to hit OK, and you can see that now we have a warning, index out of bounds, and we have a null element, and here 5, and then for 4 we start already having stuff, and for -1 we don't get anything. Okay, beautiful. But if we look at the original component, the GetItem component, it's called list item actually, you can see that it has the list, the item, and it has this thing called WrapIndex, which means that, let me show you how this works. So let's compare them side by side. So if I have this, right, and then this is the index, and if I turn this to false, okay, then whenever I go out of bounds, supplied index is too low, and if I go to and supplied index is too high. You see, this component is slightly better designed than what we did because it has two different messages, right? But it's pretty good. However, if we turn wrapping on, it turns out that it actually spits something outside, and what that is that what it does is that if you're at the last position, number 4, then it gives you the last element. But if you go to the next one, because it wraps, what it does is it calculates that the next one is going all the way to the beginning, and then if we go to number 6, then it's number 1, and we go to number 7 is number 2, number 8 is number 3, etc., etc. So it basically makes sure that whatever index you give it, even if it's too far, too high or too low, it gives you one that is proportional to how far away you are from the list. Okay, so we're going to try to implement something, because why not? What, Grasshopper is better than the components that we can implement ourselves? No way. So I'm going to add an input. I'm going to name it uppercase W, and then I'm going to say that this has to be of the type Boolean. All right, and I'm going to plug this in here as well. And then what I'm going to do is I'm going to make a trick here. And the trick is going to be that if any of this happens, what I would like to do is I would like to maybe I'm going to keep the message from now on, but instead of just outputting nothing, what I'm going to do is that I'm going to recalculate the value of I so that it stays within boundaries, but it stays in a way that is proportional to how far off it is. And the way to do that is by using the modulo operator, which I promise you sometime in the past that was very useful, because remember, if you remember, the modulo gives us the integer remainder of a division. So if the list has 5 elements and we are at position 5, 5 modulo 5 is 5. Okay? But if we ask for position number 6, 5 modulo 5 is 0. Actually, I'm sorry about that. But if I say, give me the element in position number 6, if we do 6 modulo 5, then the result of that is going to be the value of 1. So you can see how it wraps up and it goes back to the beginning. And 7 modulo 5 is number 2, 8 modulo 5 is number 3, etc., etc. So what I can just do here is I can say I is going to be equal to whatever I was modulo how many elements that list has, L.count. And then instead of returning or stopping, we let the rest of the code execute now, because this I now has a new value that has been wrapped to domain from 0 to 5. And let's see if that works. If I do that, you can see that here the elements are the same, but now for number 5, I get the index out of bounds, but I get the same elements. And for number 6 and 7 and 8 and 9 and 10, we wrap again. And what about -1? -1 does not work because we need to implement a modulo that returns a positive value, which actually that one I'm going to leave as an exercise for you, the viewer. Okay, how to fix that. But at least it's going to work for positive values. All right, beautiful. What are we doing next? Well, actually, I thought it through and I didn't want to leave it like that. So I went ahead and I wrote some code to fix the problem. So now we have, in the sanity section, we have two situations. One where I is greater than the length of the list. And in that case, we just give out one message and then we do what we did before. But then when I is negative, what I have done is, this is very, very bad code. There's got to be a better way to do this, but I've just written an I've just written a while loop and that as long as I is less than 0, it keeps adding to the value of I the amount of the amount of elements on the list, so that at some point it goes positive or 0, and then at that point we find we do this, which I think it should also be. I don't think we actually need this. Yeah, sorry, I'm really jet lagged right now, so this is probably not the best code I've written in my life, you know. Anyway, but this now should work. If I go negative, you can see that now I'm respecting the same pace of the original component, and I'm also respecting the order of wrapping correctly. Okay, beautiful. So we can then just do that and leave it like that. All right. So what is the next one that we're going to do? What about getting the branch of a component? Well, this is going to be pretty much the same thing. So what we're going to do here is we're going to get the branch by the number we're getting for this tree. For the tree, wow, I'm really jet lagged today. Sorry, I apologize. So if the tree has 15 branches, we're going to retrieve a branch not by the path name, but we're going to retrieve it by its position. So you can see the first one, you can see the second one, you can see the third one, and we're outputting them also with the tree. We did this in the previous video, okay? So how are we now going to make sure that we don't go overflow to the top or to the bottom? Well, we're also going to implement here some sanity, all right? And we're going to say, if I is less than t dot branch count, so if I is less than 0, okay, or I is greater than t dot branch count minus 1, then we can say component add runtime message Grasshopper runtime message level dot warning, and then we say index is out of bounds, and then we output nothing from the component and we stop the execution because we don't want to hit anything that we don't want to do. So if we do that, then you can see that this, let's see if we snap this negative. So if we go in negative, we get a warning, and just like it's index out of bounds, index is out of bounds, and then also here we get a warning. And if you were interested, you can also implement here wrapping, just like we did before. We can just wrap, and then we can make sure that we just go back to the beginning and start taking from the beginning. Okay, that could be another way to go. And then get by path, here we're going to do something exactly like what we did here. So first of all, what we're going to do is we're going to find the path, and then we're going to check if the path exists. Then, and if the path doesn't exist, then we're going to say path does not exist, and then b is going to be equal to no, and then we're going to stop the execution of this because we don't want to get into this whole mess. Now, if we see that this doesn't exist, okay, so this is removed, okay, and this one also doesn't work. And then here we have 1, and then we have 200, and this one also doesn't work, is the path just does not exist, okay? So we're going to go back to the original, all right? Okay, so I think this was a good introduction to error handling and to giving better feedback to users about what's going on in the components. In general, that's a super good practice because Black boxes can be nice for very beginners, but as soon as we get comfortable with any platform, we actually want to know what's going on. So getting information about possible errors and things that are not going good is actually a very good thing. Just as it is to make sure that we select and we design carefully which information the components are outputting if the user finds themselves into such errors. Okay, so this is a good thing for us, finding safe defaults for errorful situations. Okay, with this, I'm going to leave it here, and we're going to move on to the next video in this series. We're going to keep learning more about Grasshopper components and how they're written. And if you found this useful, as usual, maybe like this video, maybe subscribe to the channel, maybe turn on notifications, etc., etc. Okay? Thank you very much. See you on the next video.